Hello Internet, my name is Quinn and this is Blondihacks. I'm working on my locomotive this week and we are going to finish the Smokebox on the front of this thing. We're going to do all of the functional bits inside of it and we need a headlight bracket also, so we'll knock that out. Let's go. The outside of our Smokebox is looking proper, but now let's get the inside of it functional. You can see we've got lots of plumbing to do. We need to connect the steam inlet on the cylinders to the right-hand output of the boiler, and that output is connected to the regulator that sits inside the steam dome. So that's throttled steam effectively. That's controlled from the cab with the throttle lever. And then we're also going to need the exhaust jet that shoots up into the petticoat pipe. I talked previously about how that creates draft. That's called the blast pipe. It effectively is a steam turbocharger. It's doing the same job as the turbo on an internal combustion engine. It's using leftover energy that's still in the exhaust gases to increase oxygen input back on the combustion side. Same job. And then on the left-hand side of the boiler, there's another fitting that you can't see, a second output from the boiler, and that goes into what's going to be the blower pipe. And that allows the engineer to manually create draft. And that steam pipe actually just goes all the way through the boiler. It goes through the middle instead of around the outside of the boiler, so that the steam in that pipe stays hot as it makes the long trek from a valve that's back in the cab to the blower pipe here in the front. It's all very clever design. I'm going to start with the blast pipe, but I'm going to need to take some measurements off of my model. As I've said previously, as these major subassemblies all come together in the interface areas, the drawings become more and more of a suggestion, and I'm doing more measuring on my actual locomotive to see how big things need to be. So this is the hex bar stock I'm going to use to make the blast pipe. It's mostly hexagonal in shape so that you can put a wrench on it. So I'll face off the end, as is tradition. This is a very simple part. It's just literally a long pipe that sticks straight up out of the exhaust on the steam manifold, and it's got a nozzle in the end of it that creates a bit of a jet from the otherwise low-pressure, lazy steam that's coming out of the exhaust side of the cylinders. I've laid out for a thread on the end of that, and that's going to thread down into the steam manifold. I've increased this dimension a little bit. There's a little bit of a smooth area above the threads that's supposed to go down into the steam manifold, and I made that a little bit longer to account for the extra thickness of that spacer shim that I have sitting on top of my manifold, because reasons something boiler fitment. Next I go all the way through the part with a small pilot drill. This is the diameter of the nozzle, so this is effectively starting the nozzle at the end of the part. The way I have this set up in the lathe, the nozzle is inside the chuck, effectively. That'll make sense here in a second. When drilling long, small diameter holes like this, you really want to clear your chips often to make sure that the drill keeps cutting and doesn't start deflecting because it's all packed up with chips. Sliding the tailstock in and out is a quick way to do that. Then once that's done, I come back in with a slightly larger drill, which does not go in as far. So we've got a larger diameter that closes down onto a smaller diameter right at the end of the blast nozzle, and that forms the nozzle. It's just a large diameter hole and a small diameter hole. Nothing too fancy there. Then I pulled it out, and I'll use a grooving tool to create the smooth area that's at the top of the nozzle. I think this is just for aesthetics. I don't think it serves any functional purpose. And I certainly could have parted it off and flipped it around for this second op. I decided to do it this way, I guess as some sort of weird flex. I don't know. It worked, okay? I don't know what I'm doing. Then of course we get out the chamfering tool, because chamfers are what separate us from the animals. And it's looking good, so we can Yahtzee this off. I want to chamfer that top edge as well, so I'm going to sneak in there with a file. It's worth noting this little stunt is only possible because this is a safe edge file. I've ground the teeth off one edge. If you don't do that, you can't do a move like that with a file because the teeth on the edge are going to grab on that shoulder and it's going to throw the file at you. But with no teeth on that edge, the file can sit in there into a tight groove like that without binding up. And Yahtzee. I was relieved to see the little nozzle on the end, which means I did the math right on those drilling depths. Huzzah. Quick test fit now in the Smokebox. If I did everything right, this piece should slide all the way down into the steam manifold, thread into place, and kind of clamp down on the top of the bulkhead fitting that is at the bottom of the Smokebox. So that actually helps hold the Smokebox in place. It's effectively clamping the boiler in place. I mean, there's other things doing that as well, but that is certainly adding to the strength of everything. Now it's time to look at these output fittings on the boiler. On the right, once again, is the main steam line, and then on the left is the blower pipe. I'm going to start with the main steam line that goes to the cylinders on the right. So it's time for more plumbing fittings. I'm going to need 3 union nuts. A union fitting is a very common type of fitting in steam, especially in model engineering. It consists of a cone that does the sealing on the adjacent fitting, and that solders onto the end of the pipe. And then this nut that I'm making now slides over the whole assembly and clamps down on that cone, sealing things together. This whole assembly of plumbing inside the Smokebox uses 3 union nuts that are all the same, so I'm just making these in a batch. It's really just a counter bore inside a hex with threads on the inside of the counter bore, and then there's a little bit of shoulder left at the top which does the clamping. So the dimensions are all pretty critical to make sure everything lines up correctly, but it's geometrically very simple. And of course we always chamfer those because on a hex nut especially, chamfering the corners really adds a lot to the appearance. And Yahtzee. 2 more of those then, and that's half of our fittings done. I'm going to make up the rough cut pipe now that's going to be part of this because I want to be able to test fit on the cone fittings. Unfortunately, the pipe is too small for my smallest tubing cutter, so I switched to the fret saw to cut this length. I'm making it a little bit over length because there's a lot of bends in it and it's hard to calculate how long it needs to be, so it's a little bit over length and I'll trim it down later. Now I can make the cone fitting. I'm going to make 2 of them in a batch because we've got 2 of these fittings that are identical. So I'll turn this down to the outer diameter of the tapered area, which is the largest diameter of the fitting. Then I center drill and drill with a pilot drill all the way through the entire thing. That's all the way through both parts in this batch. Next is a counter bore that the end of the copper pipe seats into and holds the solder joint. So for this I'm going to use this square ground drill. The flutes on it are ground square, and there's this little pilot point on it. You can make these yourself, but I bought them. DeWalt calls them its pilot point drill, and they're really great for this kind of thing, for making really small counter bores in model engineering. You could also use an end mill if you have the right size, or an actual counter bore if you have one of those. But there's often a lot of odd sizes of small counter bores in model engineering, so grinding your own drills usually works the best, or you can use a tiny boring bar if you like. But you can see what a nice job that drill does. Leaves a nice little square shoulder on there that the pipe can seat into. This fit doesn't have to be super precise because it's just a solder joint, but I'll do a test fit on there just to see how it fits. Okay, well, it needs to be better than that. That's a country mile too large. What the heck happened there? I went and looked at the drawings, and believe it or not, there is an error in these drawings. And I say that with feigned surprise in my voice. This is acting, people, because actually this is one of only a very few errors that I've found in these drawings so far, which is pretty impressive considering we're talking about many thousands of parts in this book. There are also times when I think there might be an error or I might be misunderstanding something, but I think in this case it's definitely an error because you can clearly see the counter bore is labeled 7/32 and the copper pipe is clearly labeled 3/16 OD. So likely one of those 2 dimensions changed during development and Kozo forgot to update the associated dimension. The 3/16 OD is mentioned in multiple places in the text, so I think the 3/16 is correct and the 7/32 is too big. So luckily not a huge error. I just had to face off that counter bore that we just did and drill it again with the 3/16, and there we go, excellent fit. Now for the opposite end of the fitting, I'll turn down a little straight area, and this is what seats into the mating fitting, and then behind that we use the chamfering tool to create the taper that does the actual sealing on the outer shoulder of the mating fitting. This is a style of cone fitting that Kozo likes. There's lots of different styles of these things, but this is the kind that he likes, so most of the ones on the locomotive are this. So the little cone fitting goes on over the end of the copper pipe, and then the union nut slides over all of that and clamps it in place against the mating fitting. Very simple, easy to make, and these seal really well. Thus I made 2 of those, and then the third fitting I need is the cone for the smaller blower pipe. And this is of a different design. I'm not entirely sure why, but this one has a taper on both sides, which I think is just aesthetic. I can't see any functional reason for the outer taper. The inner one, of course, seals, just like on the fittings that you saw. But Anyway, for some reason, this one's different, and so I made it to the drawings. Yahtzee! I'm ready to bend the pipe into shape, so I'm going to start by annealing it because that will make shaping the pipes much easier. These straight pieces of copper pipe are shipped in their half-hard state, what's called half-hard, which is basically work-hardened in copper speak. So I heat those up to a glowing orangish red, let them cool down naturally, and now they're nice and soft. So I'll install the cone fittings so I know what the final position of the ends of the pipes needs to be. And I'll stick one in there and kind of mark where it needs to bend down. And there's multiple bends in each of these pipes. So I decided to try using my small tubing bender. I've had some success with this in the past. In one of the other plumbing videos in this series, I did a whole section of that video experimenting with all different pipe bending methods for these small model pipes. I tried filling with sand and annealing and not annealing and pipe benders and all the different things people often use, and each method has merits in different situations. In this case, I tried the pipe bender first because that's the easiest if it works, and I can tell you right now it didn't work very well. I also tried using 2 sets of parallel jaw pliers, one to hold the part on a mandrel and the other to bend the pipe. That worked, and I got a pipe that fits correctly, but it got pretty deformed in the process, so I decided to make a second one, trying a different method. What I found works really well here is setting the vise at the exact right distance to hold the pipe up against a bending mandrel. The vise jaw is not clamping at all. There's zero pressure on the pipe. It's just holding the pipe at the exact right position so I can push the pipe around the mandrel. Because it's annealed, you can use your fingers. It's fine. It's not difficult to bend. And that vise jaw holds it perfectly, and you can easily get the exact right bend you want. You end up with a nice radius, and you don't get any flat spots or other jaw marks or other distortion. And that worked really well. I ended up with a beautiful, perfectly round pipe all the way down. You can see the first one I made. It's all flat spotted and jaw marked and otherwise distorted. It's a beat up old mess of a thing. Looks like it's seen some hard miles, and yet it's brand new. So that was worth remaking again because that first one's pretty ugly. I used that same technique to do the blower pipe next. Now it's a smaller diameter, but once again, the vise jaw and mandrel technique worked really well. This one has a bunch of bends in it because it needs to bend down towards the blast pipe, and then it does a little U-bend so that it's shooting straight up the smokestack with a little nozzle that sits right above the end of the blast pipe. So it acts sort of as an artificial blast pipe to create draft. There you see me bending the first of the many bends on this. This is a very small diameter tubing, so the tubing itself is the nozzle, effectively. It doesn't need a dedicated nozzle on the end of it the way that the blast pipe does. And this steam is high pressure, so it doesn't need accelerating because this is coming straight out of the boiler. This is unregulated boiler pressure steam. It's coming from a valve on the back head, so it's high pressure already and it's going plenty fast. No nozzle required. And there you go. There's everything kind of mocked up inside the smoke box. You can see how the main steam line comes down in front of the blast pipe, and then the blower pipe sits just a little bit above the blast pipe and kind of points up the stack at a little bit of an angle to kind of aim at the center of the petticoat pipe. And in theory, that creates draft for the smoke tubes. All right, well, with the pipes shaped, I can now solder the cones onto the ends. So this is always a delicate job. I'm going to do both ends at once because it's going to be easier to just do a single heating. And of course, very, very important, do not forget to put the union nuts on first. You are not a model engineer if you haven't forgotten that at least once. And then of course, the entire pipe is scrap if you forget that. One time I remembered to put the nuts on ahead of time, but I put one of them on the wrong way. And oh, that was almost worse than not doing it at all, because it's like I remembered to do the thing, but then I screwed up the thing in literally the only way that it's possible to screw it up. Yeah, that was especially demoralizing. But this time I did everything the right way, put the nuts on in the correct orientation, put the cones on the end, everything's fluxed, and I'll solder both of these on. Normally I like to heat the joint with the solder sitting there. That's a much more reliable way to get a good joint. But with really tiny joints like this, especially on round pipe, it's easier to do the heated up and touch the solder in there method. I've got it oriented so that the joint I'm working on is pointed downhill because you can't silver solder uphill. The solder won't run into the joint. And once that one's done, while everything is still hot, I quickly lift up the other end with a wedge and do the other end with it pointing downhill. It's always a relief when one of these plumbing pipes goes well, especially with the union nuts in there and faced correctly. So let's get this test fit on there and see how it works. So you can see how there's that little straight end on the end of the cone that slots into the counter bore on the mating fitting, and then the union nut goes down over the whole mess and clamps it all together. They're really beautiful fittings, and like I said, easy to make and very rarely leak. If they do leak, you can just snug them down a little bit and the taper will seat tighter and job done. And the blower pipe goes on there like so, same deal. That is all looking very, very nice. There's the entire plumbing setup mocked up with the Smokebox out of the way so you can see what it's going to look like. Of course, I won't know for sure if all of this works until we fire the boiler for the first time, but it certainly looks the part, I guess, so it's probably okay. Who knows? Now eventually there's going to be a big headlight sitting on top of the Smokebox. I'm going to make the bracket that holds that. In my scrap bin, I found this very ratty old piece of brass plate that's the perfect thickness for this job. I don't know what happened to this poor thing. Well, I guess Quinn happened to it, but I don't know how. It looks like a failed bending experiment of some sort, but there's enough flat spots left in it to get the parts out of it that I need, so it will live on as a headlight bracket. I bandsaw cut and shaped the 3 plates that make up this assembly. This is a kind of tab and slot assembly. Rather than using tiny screws to hold all the pieces together for soldering, they get slotted together. So I'm going to cut the slots with this big thick slitting saw that is the same kerf as the thickness of the material, which makes this job very quick. This is a pretty aggressive slitting saw. This is verging on being a horizontal milling cutter, honestly, at this scale, but that went just fine. Nice slow feed, lots of WD-40, and drama-free, nice clean slots or cut thusly. You can see how the resulting slot is a perfect fit on the mating material. So that's how that's going to go together. Now I'm going to cut the same slot in the other leg, and you can see how 2 pieces with these same slots slot together perfectly, like so. And oh, that is so satisfying. I can't even tell you. Oh, that's the best. Now these are the legs. They don't actually go together like that, but I just wanted to show you how these joints work. So now comes in the top plate, and I'm going to cut mating slots for the 2 legs. Now, unfortunately, I did have to get the saw mandrel very close to the top of the vise jaw. If I put my shortest parallel under the part, then it was sticking up way too high, so I had to get it down on the bottom of the vise. There's about 15 thou of clearance between that mandrel and the vise jaw. That's a little closer than I like to be, but in machining, clearance is clearance, and there's really no other way to do this cut, I don't think. But once again, that was drama-free once I had the setup figured out. See? Lots of room. Don't worry about it. Send it. YOLO. All the things. Next, I'll lay out the U-shaped cut that makes these pieces into the little feet. They're identical, so I superglued them together, and I'm just going to fret saw out that opening. It would be a pretty heavy milling cut, and there's not a lot of material to hang on to in the vise, so I felt like doing this by hand was easier. So I fret saw all the way around that U-shaped opening in the 2 parts that are glued together, and then I separated them and finished on the die filer up to my layout lines. That actually did a really nice job. That was, I think, easier and quicker and less drama than trying to do that on the mill. Now I can slot all the pieces together so you can see what it's going to look like. Oh, so satisfying. Now those legs get splayed out to become the feet, and this little toolmaker's vise I think will be the perfect tool for this job. A viewer sent me this a while back, and it's awesome for this kind of precision bending of small parts because the jaws are ground on top and front. I hammered those over to what looked like the right angle. I kind of approximated the angle I would need for these to fit on the curve, but of course they can be fine-tuned later with some pliers. Once I'm happy with how that's sitting, then I can take it apart and drill the holes for the feet. So to do that, I need to lay out where the feet are going to go. I marked the top of the radius of each bend, and then I went down from there to create a square foot below the radius of each bend. That square foot then gives me a target for centering the mounting hole. You could do it the other way, of course. You could drill the holes first while the piece is flat and then bend it. But in my experience, it's much easier to align a hole with a bend than a bend with a hole, because bends are difficult to get in exactly the place you think they're going to end up. So with the bends done first, I can now drill the mounting holes in a place that looks aesthetically centered relative to the bend. I hope that made sense. Then with all of that done, now I can finally solder it all together. I often do the bends in bent parts first or early in the order of operations because it makes it so much easier to do the rest of the alignments, but it does often make for some, odd looking setups like you saw over on the mill there when I was drilling those holes. The silver soldering job to make this into one assembly was very, very easy. The nice thing about these tab and slot type joints is they're very, very easy to solder. You've got lots of surface area, easy angles, easy access. It's quick, there's no fiddly little screws to flux, etc. So whenever you can do an assembly like this, it sure is easy. And those joints came out beautiful. This type of assembly is very, very easy to solder and get excellent results. So now there's just a bunch of excess material to remove all the way around those joints. So I'm going to have to set this up in the mill right side up to do this because the feet stick out further than the top surface. And that means I'm going to use a machinist jack instead of parallels because there's no way to get parallels under the thing. There's no straight references on the bottom of this thing that I can use without the feet being in the way. So I'll set it up like this, and this worked just fine. And I mill down the sides down to dimension. In hindsight, I probably could have milled these sides to dimension first. There wasn't really any reason to leave them over length, but I just kind of did so out of habit when making these silver soldered assemblies. And then while I'm here, I can also machine most of the material off the tops to get those close to flush. I'll finish that with a file. So it'll be easier to get a nice result with a file. And then I thought, while I'm here, I might as well center up and do the hole pattern that's going to hold the headlight on top. And this was a really good idea, except for the part where I forgot that there aren't parallels under the part. There's a machinist jack under the part. And I realized it when I saw steel chips come up out of the hole. Yeah, poop knuckles. Well, I've put one hole in my machinist jack. I might as well put 3 in it. I didn't want to upset the setup and my DRO edge finding, so I just drilled the other 2. I mean, no real harm done. I just stoned the burrs off of that, and it still functions as a machinist jack. And now it also doubles as an eternal reminder of my incompetence. Yep. Yeah, well, those are shop-made machinist jacks, and they're not very good, so that wasn't any great loss to the world. Finally, I finished by filing all of those last little edges away to make this into a nice, clean, and smooth-looking assembly all the way around. When done well, you end up with a complex assembly that looks like one part. The joints basically all disappear after the filing. It's a nice process. It's a nice way to make these little complex assemblies, silver soldering and filing. Now to get it mounted on the Smokebox, I'm going to set it up on my surface plate, calibrating my level to the surface plate. Amazingly, the smokestack came out dead level. I don't know how I managed that, but that's good. It means I can use that as a reference to get the headlight bracket level. There's a center line scribed on the bracket and the Smokebox, so I need to get those center lines aligned and the bracket sitting level in both dimensions. And once I've got all of those things true at the same time, and it's straight, and it's the correct distance back from the front edge, it's like 5 things that all have to be true at once, so it took a lot of fiddling. But once I finally got that, then I very carefully transferred one of the 4 holes in the bracket. Just one. When doing a tricky hole pattern like this with a lot of variables, I do 1 hole at a time. I mark the first one, drill and tap it, and then put the thing together with the first screw, and then double check everything is still good, and then do the second one, and literally I do them one at a time, checking everything in between. I find that really helps eliminate errors, and if you do have some error creeping in, like one of your holes is a little off, you can slot out that 1 hole before continuing, and you don't get into a big mess at the end where you've got all 4 holes drilled and tapped and nothing lines up and you have to slot out everything to make it fit. I'm pleased to say the extra careful work paid off, though. I ended up with a headlight bracket that is dead level in both dimensions, and as far as I can tell, perfectly centered. So, can't argue with the results. That is excellent. Very pleased with that. All right, let's get things fitted now, and here's where things get interesting, because of course we need to get that pipe in there, but there's really no way to get a wrench on that. As you can see, there's going to be no way to tighten that nut in there. So what do you do about this? Well, a couple of things come to mind. The first would be a crow's foot. No, not you. Get out of here. You guys cause nothing but trouble. Sorry. If you're not familiar, a crow's foot is a type of wrench offset that uses a socket extension and allows you to get around things, but there isn't room in there for one of those. Another option would be some sort of custom dogleg wrench that would fit down in there, and I considered making one of those, but what Kozo suggests in the drawing is modifying a nut driver. I didn't want to actually modify any of my nut drivers, however, so I went down to my local hardware store. They have a secondhand tools bin, and there was one nut driver in that bin. And can you believe it? It was the exact correct size. Truly, Metallicor, the god of machining, has shined upon me this day. Yeah, it's actually kind of a nice one. It seems a shame to modify it, but it cost me less than a cup of coffee, so modify it I shall. What needs to happen is I need to cut a slot in this that will allow me to slip it over the pipe with enough clearance to do a partial turn on the nut. This called for some precision surgery with an angle grinder. While I was doing this, a little birdie told me that it wasn't clamped down quite firmly enough. That little birdie's name was Physics. Once the shape was roughed in, I fine-tuned it a little bit with one of those little grinding wheels on the Dremel tool. I did a lot of test fitting that I'm not showing you here because it's not very interesting, but here's the end result. Very beautifully done, as you can see. Shut up. Anyway, it slides over the pipe and allows you to get a purchase on that nut, and then it's got enough clearance in it that you can get about 90 degrees of rotation around the pipe, which is enough to tighten the nut down in a couple of passes. Or if it's already mostly tight by finger, then you just have to snug it down with, a 60-degree turn or something. So let's give this thing a whirl and see if it works. Of course, you're not going to be able to see in there as I finger tighten those nuts. I did find I have to remove the petticoat pipe to get in there. The clearance is very tight in there. Figuring out the order of operations for maintenance here. So, of course, my hand is in the way, but hopefully you can kind of make out what I'm doing. I can get a little bit of a turn on it, maybe 60 degrees, and then come back in, reset, and do another little bit. It's a little bit awkward, but it does work. And I think it was easier than any of the other options, possibly the only option. Kozo has learned what automotive manufacturers have taught all of us, which is that there is no design problem that can't be solved with an expensive custom tool. If you'd like one, this is custom tool BHKZ17462. It costs $4,600 and is only available through our preferred dealer network, which costs $1,500 a month to join. Next, I'll narrate the reinstallation of the petticoat pipe, just because it gives me another excuse to say the word petticoat pipe. That is the most hilariously named component in all of steam technology. There it is, the completed Smokebox interior, looking very functional. As I said, I don't know if this is all correct. I can certainly fine-tune things like the shape of the blower pipe. It might need a little adjusting, but we'll find out when I run it for the first time. And there is the completed Smokebox, complete with headlight bracket, ready for the headlight. It's certainly looking the part, and it should now walk the walk as well. I've really enjoyed making the Smokebox. It's been quite an intricate assembly and a lot of interesting operations that are different from some of the other stuff we've been doing. So I hope you enjoyed watching it. Thanks so much to my patrons for making all of this happen, and I will see you next time.